Hi everyone, today I'm going to be solving the Leetcode question, maximum points in an archery competition. I'm going to assume that most people have already read this question, so I'll just give a quick summary of what we're trying to solve. So we are told that there are an array of points which are from 0 to 11 inclusive, and for each section there is a score of k, which is basically from 0 to 11, which is the index that we're on. So if Alice and Bob have shot AK and BK, um, you are playing as Bob, and you need to have more arrows hitting that position than Alice. So you have to have one more than Alice in order to get points in that position. But um, if no one has any points in either position, then nobody takes the points. So, for example, it's also giving an example where if Alice had shot 2 arrows on positions 11, then Alice takes 11 points. But on the other hand, if Alice shot zero arrows on a section and Bob shot 2 arrows, then Bob will take the 11 points. So what we're given is that we need to solve this problem and return the array of where you can get the maximum number of arrows. And you're given a couple examples here of different solutions for this problem. So there's many different approaches to solve this question, and I will go over a backtracking based solution because in order to solve this we'll have to use some sort of recursion, and backtracking will be able to remove some of the overlapping subproblems. So I will share my iPad of how I will solve this approach. This problem, what we're going to do is we have two different approaches, and we're going to use backtracking. For backtracking, there are two different ways. So we have an array from 0 to 12, and in order to get points, we need to score more points than Alice in each of these positions. So there will be two different subproblems. One in which, in that particular index, we will use the arrows to that we have to gain those points. Else, or on the second chance, what we can do is we can just skip that index and go to the other ones. So that is basically the idea of this problem. There's only these two different choices that you can take. And if you know backtracking, this is actually a pretty straightforward problem. And this is how I'm going to be solving this problem. If you hadn't had a chance to do it yourself, I would highly recommend that you try it out and then come back to this video where I'm going to solve it on the website. So now I'm going to solve this problem. And to do that, we're going to create this variable for Bob first, which is going to be the result value, which we're going to populate at the end. And then we have to do a recursive function where we're going to use backtracking. So we'll create that function, which is going to calculate the points. And in this function, we're going to pass the number of arrows, Alice arrows, and then Bob, as well as the index that we're going to start off with, which is going to be 11 because that's the max index. We're only going up to 0 to 11. And then, so that's this function. And then let's create this recursive function here. Calculate points. So we're going to have the number of arrows here. And then int r Alice arrows. And then we'll have the Bob for the current one, and then we'll have the index that we're currently on. So these are the parameters of this index function, and just going to be a public void. It's going to be a void function, so it's not going to return anything. And all we're going to do is populate this variables. And then so we need a base case condition, and the base case is to stop the recursion. It's going to be when index is less than 0. So usually when I'm doing recursion, I like to put the base cases first. So when index is less than 0, or remaining arrow is less than or equal to 0, then what we're going to do is if the remaining arrows and this is actually called number of arrows, right? So number of arrows is less than that, and then number of arrows is greater than 0. Then for whichever the last index, which is just going to be the last one, and you don't even get any points here, so we're just going to add plus equals the number of arrows that are remaining. Else, so we also have to check, so the current points that we have. Oh yeah, and then so we also have to pass the points that we have. So there will be another here, which is going to be in number of points. So if points is greater than the value that we have as max points, and I haven't set this variable yet, so all we actually need it as a global variable. So we're going to do int max points equals 0. And then we're also going to have the final array as well as a global variable. So we're just going to do bob max equals new int 12, right? So this is what it is. And then if the points is greater than that, then max points, we're going to set it as points. And then also we need to populate this variable. Where we're going to do a populate of bob max equals we want to clone this variable, so we're going to have to do bob dot clone, and then so we're just going to get the same array, and then we're just going to populate it in the bob max. And then what we do is we can just return from this function, because that's the end of the recursion. So that is the base case that we need to have for this recursion to work. And then if we want to solve the rest of this problem, we're going to need to have the two different cases that can be there. So if the remaining the number of arrows is greater than Alice arrows and then the index that we're currently on plus 1, then because we need to have at least that many, and then it's actually greater than or equal to. In order to beat her, we need that. So we'll also put these brackets in case it gets messed up. And then what we do is we do bob index equals Alice arrows index plus 1. And then we'll do a recursion. So this is where the backtracking comes in, where actually if this is not the max value, then what we would do is we would just set this equal to 0. So that's backtracking, and then we're going to call this function again, calculate points, and what we would pass is number of arrows minus Alice arrows index plus 1. So we'll just copy this whole thing. And then Alice arrows bob, and then we'll do index minus 1, and then points will be points plus whichever index that we're on. So the index is the value that we put here, because each of the indexes are just going to be like 0, 1, 2, 3 to 11 points. Okay, so that is what we call, and then that's the base recursion. And then also we have the other choice where we don't actually use the variables here, where we don't populate this function at the index. And that is the second case where we're going to call calculate points again. Number of arrows will remain the same. Alice arrows remain the same. Bob, then we do index -1, so we'll go to the next one, and then points remain the same. So that's the other recursion. And then again, we do backtracking, where we would set this index equal to 0. So that is how we do this backtracking solution. And finally, at the end, what we'll need to do is return this Bob max, where we have populated this value. So if we set up everything correctly, this should be the answer to this problem. So let me just run this code. Let's see what is going on. Calculate points. Oh, okay, yeah, I forgot to put a comma here. Yeah, and it looks like it was accepted. And finally, when we submit this problem, it works. So yeah, we were able to beat 66% of the submissions, and it's working correctly. So that is how you solve this problem. We're using a simple backtracking based solution, and we have two different recursion calls, which are going to be 2 to the power of n. But because of backtracking, it's going to reduce the amount of calls that are actually made to an n squared solution. So that's how we solve this problem, and as you can see, that's the solution. So if you have any questions, please let me know in the comments below, and please subscribe for more videos in the future. Thank you.